All right, let's get started, and then I'm sure we'll get a few more people joining during my introduction. Um, so welcome to this new meetup. This is June 24, HPE Developer Community Meetup. My name is Didier. I'm the tech lead for the HPE Developer Community. Today, we are very pleased to have a partner of us, Thales, invited as a speaker to talk about implementing centralized key management in HPE GreenLake with a solution from Thales. So we have Jeff with us, he'll be our main speaker. We also have assistance from Chris, and we have also a demo that will be delivered by Jerome from the CIC. Before I hand it over to Jeff, let me just give you a few background information about the dev community. Maybe you're not familiar with this. We have these meetups that we run every month, and we started this almost more than 2 years ago now. We have a talk coming up in July on GPU programming with Chapel. It's a talk done by Jad and from HPE, and this is a confirmed talk. I'm working on a few more options for August, but there will be a meetup in August. I cannot just tell you the title right away. And meetups are a little more in-depth, open source or product-specific technologies, which we provide with either HPE speakers or partner speakers, like it is today. We have another kind of talks called the Munch and Learn, and these were started even longer ago, like 3 years ago. And we have a page, we have a meetup page, and on this meetup page you can find the upcoming meetup for July. And by the way, in the Q&A, Denis and my colleagues Frederic will drop all the links to join this session, so feel free to register for that. The Munch and Learn is a little bit different. It's delivered by HPE thought leaders, fellows, and DTs. And we talk about more like industry trends. We try to stay vendor and product agnostic. Unfortunately, I don't have a confirmed title for July. I have to say that HPE Discover was in the middle, and it didn't help me finding the speakers for July. We think we're going to have one in July, maybe on the 17th or on the 24th, but I cannot confirm yet the topic. So stay tuned. The page is Munch and Learn. You can go check for that page, and we'll update it as soon as we know. Another point is the Meetup and the Munch and Learn replays are all available from our YouTube channel. So once we go through the asset program process to get the video clean and edited, we put it in the replay link in the Meetup page or the Munch and Learn page. So you can find all the links for that in those pages of the previous sessions. This one will be available before, I would say, the end of next week. So that will be quick. In addition to webinars, we also have another great way to learn new technology called the workshops on demand. If you go check this URL here, Hack Workshops, you'll see that we have a catalog of more than 30 workshops that you can book 24/7 from anywhere on the internet and free. These are Jupyter Notebook-based workshops, and you can follow along and run different cells to get actually code executed. So we have lots of topics covered, lots of open source topics like Docker 101, Kubernetes 101, programming languages covered like Python, Rust, and you can learn what's a REST API or that kind of basic stuff. But we also have product-based workshops on OneView, on programming Redfish. So feel free to take a look. And if you do try one of these, you can even use that to train partners or customers. But if you do use those, please provide feedback. You know, if you think we are missing something, give us feedback and tell us what it is. If you think it's a good way to train people or to learn yourself new technology, give us also feedback. This is a community, so we need your help to amplify and contribute to continue maintaining and nurturing this community. If you like these talks, please don't hesitate to forward and invite others to join those talks. We have a monthly newsletter that you can sign up on our website. We send every beginning of the month an update and You can follow and make sure you don't miss any of our blogs or any of our upcoming talks. We have a dedicated Slack account as well called HPE_developer if you're a Twitter X kind of follower. If you're a subject matter expert, like we have a good panel today, and you would like to contribute, for example, a blog, we have a system that is quite easy to use. It uses Markdown or rich text format, and all you need is a GitHub account to contribute. So feel free to take a look. If you want to jump in, it's always possible. You can also reach out to us to deliver one of these meetups or participate to events like Discover events. We have these workshops on demand I already talked about. If you think there is a gap and you can help with a particular workshop on demand you'd like to build so that we can deliver it again, feel free to reach out to us. That's it for me. There's all these links are available for you to copy. I think Denis has put all the links also in the Q&A. You can use the Q&A after my intro to ask questions to Jeff, and I know Chris will be trying to answer while Jeff is busy talking. We also have the chat and the Q&A. I think I would prefer if you keep the question in the Q&A and discussion in the chat. So if you can make that. That's it. You can scan that code to get all the links here in one shot. And with that, I will hand it over to Jeff for the real session now. Thank you, everyone. And it's all yours, Jeff.
Okay, today's talk is HPE GreenLake with Thales CipherTrust Manager. And we're going to do a quick intro here shortly. So the flow of the presentation is an introduction. We're going to do a quick review of encryption. We're going to talk about what is CipherTrust Manager. GreenLake and CipherTrust Manager together. Jerome is going to give us a great demo. We'll talk about further resources available for information and a Q&A placeholder. Okay, we have three speakers today. Jerome Gisette from HPE, Jeff, myself, and Chris Graham from Thales. All right, let me just minimize something so I can see the slides. So I think everybody here, I hope knows that HPE GreenLake is the worldwide leader in hybrid cloud. And what some of you may not know is that Thales is the world leader in data encryption and data security. So bringing the two together, bringing the two together and their products together brings that capability to hybrid cloud platform, to the hybrid cloud platform and those organizations using GreenLake. So I think to understand what we're going to be talking about, we have to do a quick introduction and overview of encryption. So this is a very classic encryption example. It's called the Caesar algorithm. It's super simple. Of course, it's not used today, but you have a message, move our armies in clear text, and you apply a key that will move those characters by 3 characters. And by moving those characters by 3 characters, you create a ciphertext that is an encrypted message. And hopefully your enemies don't understand that message. They can't read that message. So to decrypt the message, you simply subtract each of the character positions by 3, and then you move back to the clear message, move our armies. So, this is a very simple example, but if you can imagine the key as being, an algorithm and a 256-bit key like today, you can see that that without the key, you can't read the message. But also, you can also see that keeping that key a secret and controlled is critical to ensure that your data is safe, right? So there's a couple different types of keys, two main keys. One is symmetric. What do I mean by symmetric? So as you see in the diagram over here, there is one key both to encrypt and decrypt the data. It's very fast. It's commonly used in data encryption of large pieces of data. The most common algorithm today is called AES 256. But there are some challenges to symmetric keys. That is, how do you share the key, right? How do you securely share that key that really controls access to your data? Not only how do you share it with an individual, how do you share it in a group setting? And then how do you know that encrypted data really came from Caesar in our example previously, right? So that's some of the challenges to symmetric keys. So to get over those challenges, there's something called an asymmetric key. That is, you have a public and private key pair. And that's, both of these key methods are very, very common use today. And really without these key methods, the internet is not secure and you can't do anything in terms of security on the internet. So again, asymmetric keys, it's a key pair, a public and private key. They're mathematically linked. How it works is, each sender, each recipient has their own private key and their own public key. They share the public key. So you can think of as a public key as like a mailbox address. That's a very common analogy. So everybody knows the mailbox address, but only the recipient can open that mailbox and decrypt the message. So there's a lot you can do with these key pairs, right? So everybody has their key pair. Only the recipient can actually decrypt the message, but anybody can send a message, and you know that it came, it was encrypted properly because only you have the private key to actually decrypt the message and make sense of it. You don't necessarily know who it's from, though. And that is another problem that we won't dive into. But you can also use asymmetric keys to actually securely send symmetric keys to your recipient. So you ensure that only the recipient can actually decrypt the message and receive the symmetric key by using an asymmetric key. So just to make sure everybody understands what an asymmetric key is, SSH is a very common use of asymmetric keys. HTTPS, so when you securely connect to a website, you're using an asymmetric key. So that's really how common it is today, right? So any secure website on the internet is using asymmetric keys. Okay, so we know that keys are critical to accessing and controlling encrypted data. So you can encrypt the data, but if you don't control the key, you don't manage the key, then anybody can read that data that has that key, and that defeats the whole purpose of encryption. So there's a level of control of these keys, and to the left is where you're using like integrated cloud services to control the keys. So if you're deploying data in your cloud and you're using built-in encryption in the cloud and you're using built-in key management in the cloud, then your keys are generated and stored in the cloud to decrypt and encrypt that data in the cloud. That takes away a lot of the control from the organization. And in today's zero trust model, a lot of organizations look to take back a lot of that control. So as you move more to the right of the slide, we have BYOK at the top there. That's bring your own key. So that's one level of control an organization can do, and that is that they will upload their own key into the key management service, and they will ensure that, hey, I as an organization generated that key. It's not reused, somehow reused within a cloud environment. And at least I know I generated that key and when it was generated, and I can rotate that key manually. As you want to take more control, you can host your own keys. So that's what HYOK means. That means that on-prem, in the organization or in their private cloud, they can host their own key. So they have their own key management service. They generate all of their keys on site. They rotate all their keys on site. They have full control of those keys, and only those cloud services that are authorized, or those services, period, that are authorized to retrieve those keys can decrypt or encrypt data. And then the full control is bringing your own encryption. And that is that not only do you control all of your keys on site, you also do all of your encryption and decryption on site. So nothing that is sent up to the, to like a cloud service provider is clear text. Everything is encrypted before it ever hits the cloud. So no matter what is occurring in that cloud, or if there's a bad actor anywhere, it's encrypted before it leaves your organization. So you have a lot more protection and control. And again, this is about zero trust. All right, so what is CipherTrust Manager? So it's best to thought as to think of CipherTrust Manager as really a modular security platform. Yes, it's a software. It's deployed, as a physical appliance. It's deployed as a virtual machine. It's an entire machine from a secure operating system all the way up to the interface. It has the highest level of, for example, FIPS 140-3 certifications. But it's a modular platform, so it has a lot of security uses. So the three main security uses are, discovery, find the data that needs to be protected, protect the data. So that's encrypt or tokenize that data, and then control the keys to that data. So again, without the keys, you don't have access to the data. This, we're going to do a demo. I just, in case there's anything wrong with the demo, this is a quick screenshot of the front end GUI for CipherTrust Manager. Each of these tiles, which are the squares on the screen, represent one of those functions that we saw in the previous slide. Okay, so we know that CipherTrust Manager is a security platform, right? That has all this function. We know GreenLake is a great hybrid cloud platform. Number one, matter of fact, that has all these capabilities, whether it's compute, file storage. So bringing them together brings this security capability into GreenLake for those organizations. Not only GreenLake, but as GreenLake interacts with public cloud providers as well, you can leverage the security functionality of the platform CipherTrust Manager to control the data, the encryption and decryption, and to control those keys on those cloud providers that are connected to GreenLake. All right. So it's important to understand responsibility. So again, GreenLake provides, compute, storage, networking with Aruba. You can run as bare metal. You can run containerized. You can run virtual machines. HPE makes sure that platform is very secure. They handle the infrastructure security of GreenLake. The containers and the virtual machines running on GreenLake, that responsibility depends on where you're getting those containers and virtual machines. The data that you are putting in GreenLake and connecting to the cloud, that is the customer's responsibility. And by using like a platform like CipherTrust Manager, that gives you control as a customer organization using GreenLake to control those keys and to decrypt and encrypt the data how you choose. All right, so what does this actually look like? Like if I was gonna order, or I have a GreenLake today and I want to deploy something like this. So HPE already pre-sized, pre-tested, did performance optimization of using their pro-reliant DL325 platform with CipherTrust Manager. So today it's very easy to order. They already have part numbers to order this. So you have a DL325, you have CipherTrust Manager running in a virtual machine using a hypervisor like KVM, and that is deployed in GreenLake. One thing I do want to mention here, keys, I think as, I've reiterated a lot here, keys are critical. So without the keys, you can't decrypt your data. So just like in storage, when you're thinking of high availability and what is my RAID protection and what's my chances of losing data? Well, if you lose your keys, you lost your data. So no matter how rigorous your RAID is, if you encrypted that data and you lost your keys, you lost your data. So with that said, always treat storing of these keys as just as critical as choosing your RAID technology for your data. So you always want to have an HA type setup to ensure you can always decrypt your data as needed. You always want to back up your keys, so always think of that. And there are services available to make this easy and to streamline deploying this solution in GreenLake. So if you don't have those skills within your organization, you can always use services. There's also, of course, great training programs available as well and certification programs available. Just always remember though, if you lose your keys, you lost your data. So treat it just as important, just like protecting data via a RAID array. All right, so now we're at demo time. So Jerome, do you want to take over and show your demo?
Yes, of course. Thank you, Jeff.
Yep.
I'm Jean Justet, solution architect working in Geneva in the Customer Innovation Center, and we are working with Thales for months now to build and publish a demonstration around CipherTrust Manager. So what I will showcase to you today will be an integration between Thales CipherTrust Manager and DL servers and the ILO chip, and showcase how to encrypt data on servers thanks to this specific link. All the content you will see today in this demonstration is available through the HPE demonstration portal, so don't hesitate to connect, to book a demo, to reproduce what I will show you today. So I will start by sharing my screen, and you will be able to see the demonstration. Okay, nice. So what you can see here, yes, is the main page of CipherTrust Manager. So on this instance, which is a virtual machine deployed in our data center, this instance is renewed every time someone is connecting to the demo to test it and perform the demonstration. But I started to configure it just before this session, just to shrink a little bit the time of the demonstration. But just to let you know, what I did prior to this demonstration is creating a user named ILO user that will be used to onboard servers into CipherTrust. I created a group, ILO group, on which we will be able to onboard servers and users created for each servers. And I created a master key. And you can see what I did also. I onboarded one server, so a DL server that is already encrypted. And what we'll do together is do the same things on the second one. So basically, what's done here is we have to onboard each individual servers to register each of them on CipherTrust Manager. So to do so, it's not so complicated at all. You have dedicated, sorry. Cancel. Yeah, you have a dedicated entry here when you're on the ILO administration key manager. So what we did so far prior to this demonstration is to link the ILO to the CipherTrust manager instances. So you declare the CipherTrust manager FQDN port, and what you have to do is to use the ILO user already created on CipherTrust to onboard your servers. Automatically, your server will create one new user on CipherTrust Manager based on ILO-MAC address of the ILO. So for the two servers I onboarded, we will see on CipherTrust two dedicated users linked to the two servers I mentioned before. So the first one, I did everything, and what we will do is to do the same thing on the second one. So basically, as soon as this link is established, the ILO will act as a broker to let the smart array card communicate to CipherTrust through the ILO to request new keys to encrypt the local data on the server. So I already started the smart storage administrator. So by the way, at the end, I will show you how I'm doing that using Redfish, by the way. But for the sake of the demonstration, we are asking users to connect to the tool to perform all the action in a smooth way, I would say. So what you have to do is to connect to the smart array. So there is a compatibility matrix. Not all smart arrays are able to perform this kind of action. So there is a compatibility list. I encourage you to take a look to this. I can share you the links, by the way, about the compatibility. So what we have to do to configure this smart array, and what will be done here is that we will have one key that will be created for the smart array, and then one new key created for each drive that will be part of the volume we will create. So what you have to do at the beginning is to connect. So is here to open this encryption manager and perform the initial setup. And as you can see here, we already performed the integration between the ILO and CipherTrust prior to this demonstration. But here we don't have to give information regarding the CipherTrust IP address or CipherTrust credential. To create and grab the keys. Everything is done automatically from the ILO. So the only thing you have to do is to create a password, because to enter this menu later on, you will need this password to change the encryption manager configuration. So you have to put a very secure pass here. And to repeat. Okay. Encryption mode, and then disable future plain text volume. Enable disable future plain text volume. Okay. Remote key management mode, we want to use CipherTrust Manager. And the only thing we have to provide here is the ILO master key, the master key name we created on CipherTrust. It's needed to generate a new one. We already generated that specific key. So it's the ILO master key. So the only thing you have to do here is to provide on the form the name of the key that will be used to generate the new one. So I will do it here. And click on the OK button. You have to check. You have to read everything, by the way. You accept. And automatically, so the smart array through the ILO will contact CipherTrust Manager, and a new key will be generated. So as you can see here on that list, I have only one smart array in the list. So by loading this page again, we will see the second one that will appear in a short amount of time. So here it will be done. Oh, I have to accept. And in a short amount of time, it will be visible in the CipherTrust Manager. We have to wait a little bit, just because I missed to click on the accept button. Okay, so it's done. So the configuration is over on the server. So yeah, maybe I will come back, load again this page, and we will see the second controller here. So we generated a symmetric key that is attached to this smart array controller. And now every time we will add a new drive on the volume linked to this smart array, automatically new keys will be generated and used to cipher everything on the disk. So this kind of feature is quite useful. I mean, when you have to send, for instance, the disk to the support, so that means that every time you remove a disk, you have a failed drive on your system, you know by default that all the data stored on the disk will be ciphered by default. You don't have to manage, you know, all the data that are inside because everything is ciphered. So for instance, we'll create a new red volume, and what you will see in CipherTrust, as soon as a red volume is created, is that we will have one key per drive that are part of the array. So we just have to decide what kind of red volume we want to create. It's up to us to decide. Let's say red 6. You create your logical drive. Yes, I want to continue. And same story here. As soon as a red volume is created, we will see here on the logical device that all our drives do have now this little keys here, this little symbol saying that we have keys that are attached and that are ciphering, you know, everything on the volume. If I come back to CipherTrust Manager, if I load again the content, we will see new keys that has been, you know, created for each individual drives in our volume. So the purpose of this demo, when you connect, is to do it directly on live environment. So we have a server, we have a CipherTrust Manager that is attached. And just for your information regarding the capabilities on our HPE servers, so we are able to encrypt so smart arrays, drives, NVMe drives, and persistent memory. So you know that persistent memory is not a topic right now, but it's part of the things that are possible to do in our with our HPE servers. So I encourage you to connect and to test it. One of the use cases that we also built, because Jeff mentioned that, yeah, you know, with GreenLake, we are interacting as well with public cloud providers. We created a demo around, you know, the KMIP integration. So between CipherTrust Manager and Azure Stack. So basically what's done here is that we are using CipherTrust Manager, you know, as our central place to manage all our keys that are used in public cloud platforms. So what we are doing basically here, we have an Azure tenant, okay, in the Geneva CIC. And what we are generating keys. So keys sometimes are generated on Azure. We can generate keys from CipherTrust and just exchange the keys between both platforms. That way, that means that our security officer is able from one place, CipherTrust Manager, to see what are the key utilization in all the platforms that are part of our organization, so which is very helpful. So for this, so this kind of demonstration will be published soon, but so it's a test server that is here. So, but the overall idea is to really use CipherTrust Manager as a key place to manage all the keys that are used in the organization and avoid using, you know, self-signed certificate or keys provided by the cloud providers. Okay, so that's all for my demonstration today, but feel free to contact us if you want to have you know, more session, more information about what we did together with Thales. And by the way, we'll have more demonstration that will come. So transparent encryption use cases that will come in a short amount of time before the end of the month. So stay tuned. Thank you for your time.
Thank you, Jerome. We have plenty of time. Chris, do you have a transparent encryption demonstration we could show as well?
Sure.
All right. So what we just saw is the integration of CipherTrust Manager with ILO to encrypt SSDs on servers, as well as managing keys both within GreenLake and to cloud providers. So now we're going to show another functionality of CipherTrust that you can use within a GreenLake environment. And this functionality is, hey, I have a file system or I have a directory. I want to encrypt it. Well, you can do that with CipherTrust as well. So not just at the block or as device level, but if you have, you know, file systems that you want to encrypt, you can do that with CipherTrust Manager as well.
Yeah, absolutely. Thank you, Jeff. So, like Jeff mentioned and what Jerome showed, right? That was an example of using the key management functionalities of CipherTrust Manager to provide encryption keys for an external service. In this case, an HPE server. Similar functionality can be done for enterprise storage arrays, VMware, some database systems, uh, you know, many other things. It uses an industry standard protocol called KMIP, Key Management Interoperability Protocol, and it allows us to really have a very vast number of integrations that we can provide for providing that key management capability for those platforms. However, if you want to, kind of delve into the realm of providing a little more granularity in terms of what's encrypted on the system, and provide some access control capabilities in terms of who can access that information on a server, we do offer one of our connectors called CipherTrust Transparent Encryption, and this is a data at rest encryption functionality similar to what we just saw, but it allows you to define policies, to apply, various access controls to data on a system, depending on your needs. And so, we saw this interface before. This is the administration GUI for CipherTrust Manager, and here we have our transparent encryption tile. Once we go in here, we have, can see a list of our clients. In this demonstration environment, I actually have a Ubuntu server and a Windows server. We'll focus on the Windows server for this demo. But if we go further down on the list here, we can see we have policies. In that case, I want to focus on our protection policy here for transparent encryption. It's called restrict secret data. This was created in advance, but as you can see here, they're not too complicated to build out. It kind of works similar to a firewall rule set may work, in that you kind of define who and what you want to have access to certain data, and then at the bottom of the list, you might have a blanket deny of what you don't want. If we kind of read through this policy, we see that we have a line at the top that'll, because this particular policy uses an extension to our functionality called live data transformation, which allows for zero downtime initial encryption and rekeying of the data. We have this rule set in here that allows the system to go in and actually perform encryption or decryption operations on the data protected by this policy. And that's what this effect is, this permit apply key. Then we have a rule set here that, for admins, and this is a user set that's that's defined elsewhere in our policies. But if we look at it, we can see that there's a couple of users in here. These are local users on my test system, but we do support connecting to Active Directory, LDAP, external OIDC or SAML providers, all for getting user information as to apply policies to. And so we see we have our administrator, and then this is actually my own local user account in this machine. And this user set is defined to for any operation that they're doing to permit it and audit it. But what you'll see is missing is this apply key permission, which means that when a member of this group does attempt to access data, they'll be allowed to access the data, but will only be able to see it in its encrypted form. Now, if we look at this allowed users group, right, we see we have one user account in here called good guy, right? And this user account for all operations is, allowed access, and it's apply key, right? So, users in this group will be able to read the decrypted form of the data. And then if neither of these, positions are met, then we fall out to this deny audit, which means we will deny access and audit the attempt. So let's go back and look at our actual client again. If we look at our Windows server, what we have here is something called that we call a guard point on the server. If we look here, we see that we have this guard point defined with the policy name which we just looked at, which was restrict secret data, the path that we want protected. In this case, there's a directory on the on the root of the C drive called secret. And that's about it, right? There's, we have some other options in here if we want to require multi-factor authentication, so on and so forth. But what does this look like, when we access the system? Here we are logged into our Windows server as good guy, right? And here's our C secret directory where if we look at it, we can see we can read the data in this file, right? And that, it's important to note here that we didn't have to do anything special to be able to decrypt this file and read the information, right? Even though it's encrypted at rest, right? Because it's transparent encryption, we operate at the file system layer. That decryption is happening in the background whenever we go to access the file. But if we log in as administrator, right, and attempt to access the same file, we see we can browse to the directory, right? But when we try to open the file, what we get is what we call ciphertext, right? This is the encrypted version of the file. We are unable to read the clear data. Now we are able to copy files, right? If we want to, copy this as, this might be simulating taking a backup of the file, right? As we're administrator, we're responsible for backing up the data. So we can, make a copy of this file somewhere else, but you'll see that even though we copy it out of the protected area, it's still encrypted, right? So this is, a good way to, maybe ensure that the data in your backups is encrypted as well. Now, if I log in as our bad guy user, let me log out of the administrator. So if I log in as a bad guy user, right? So this is a user. Oh, that's in my Ubuntu server. Apologies. I want Windows. Remember, bad guy was not in either of the groups that we showed in the policy. It's not in the admins group. It's not in the allowed users group. So as a bad guy, if I attempt to access data in the C secret directory, right, we'll see that I get an immediate access is denied, right? So I can't even browse the directory which is covered by that guard point. And it's worth actually noting that we don't just protect and do access control for user accounts, but we can do so for trusted processes as well. So we can actually do a hashing and signing process on any application that happens to reside on the system and define a policy that only allowed processes are allowed to access data as well. You may choose to use this to protect a database file, for example, and only allow the database process itself to access that database file. With that, Jeff, I'll turn it back to you.
Thank you very much. I've been plugging away on the questions. So I'm glad we have so many questions because that means people are curious and asking. They're interacting with the presentation. So there's a lot of resources out there. This is simply a screenshot of resources available. Whether it's how is CipherTrust Manager integrated to ILO, and how is it set up? The CIC demo goes through that. There are actually instructions, white papers, service instructions on how to do these various configurations, right? Along with how do I engage services, for example. So it's something that was just published. Is how do you use services to make it easier to deploy solutions like this in my organization. Additionally, Jerome from the CIC, they have these demos. We have demos live today, and we have demos that we're going to publish. Jerome, do you want to talk about the CIC a bit more on this slide?
Yeah, so what we did together is this first demo, so HPE ILO integration, and we worked on several others that are running. I mean, in the center, but we need to publish them in the demo portal. So the next one will be the SQL one. You saw that the Azure one is up and running, and in fact, we already had some nice discussion with customers that came here and are interested in this kind of topic. And yeah, we are pleased to see that a lot of people enjoying this kind of demonstration. So we organize several workshops with customers on this topic, and yeah, we hope to see you all using the demonstration we built together with Thales folks. And don't hesitate to come back to us. I mean, if you have new ideas, if you reach out to some, if you have some issues on the environment, don't hesitate. We really are here to help you using it and yeah, show what's possible to do.
Yeah, and some of these demos aren't visible by default. So just reach out to Jerome or any of us here speaking today, and we'll help guide you to get those visible, so you have access to the demonstrations. And we want you to use the demonstration, so we encourage you to sign up and go through the demonstrations. Okay, Q&A. I think we're doing pretty good here. So let me just stop sharing so we can see the Q&A and how we are doing.
While we do that, I will start the end of session poll, and we can continue the discussion and answering questions. But yes, more or less, we answered a lot. Thank you, Jeff and Chris, for doing that. We have a few more there. I don't know if we can answer them live. We have a few minutes left, so.
Yeah, we absolutely can. So, Chris, do you want to answer the licensing question at the top?
Sure. So the question is, how is CM being licensed? Is it a pay-per-use manner, or is the number of keys, storage capacity, et cetera? For the ILO model, right? So this uses our KMIP connector functionality, and so the licensing there would be, however many number of servers you are protecting, there would be a KMIP license required for that. There's of course also a license fee that's associated with the appliances as well. So there's that. We do offer both perpetual and term licensing. So there's flexibility in terms of the way that we sell the licensing. But in terms of the KMIP connectors, it's per server connected. The transparent encryption that we showed, that's per server, per file server that you're protecting, right? So it's not based on data size or number of keys or anything like that. It's strictly the number of servers you're protecting.
Yeah, thank you. And usually, it's like a pack, like 5 or 10 connectors at a time. And that bundle we showed earlier, it already comes, I think, pre-bundled with 10 connectors, licensed, and then you could just purchase more as required. So you purchase it as you need it. So the next question is, do you have a KMIP client that runs on Linux that interfaces with CipherTrust Manager? And the answer is client or agent. So if you're going to encrypt the file system on Linux, then you use the agent. And yes, we have an agent. We have an agent for all the major Linux distributions. It's important to know that you have to look at the compatibility chart and make sure that you use the right kernel level, because the agent actually runs, or part of the agent actually is a kernel module, so it has to be compatible with that module. And it has a lot of protections built in. So for example, like if you're root on a Linux machine and you sudo to user 101, you don't have authority as that root, that sudo to 101 to actually read 101's keys. So the agent knows, because it's working with the kernel, that root user sudo to 101. And so it knows the login method that root used to become, user 101. So the agent has a lot of built-in capabilities like that to help protect the system, right? And again, it's all about zero trust. So if root shouldn't have access to 101's data or keys, right? So that that's the reason. Zero trust mentality. If root's not supposed to have access to it, then we block it. I hope that answers your question.
And I'll take the last one, right? The
Sure.
last question says, does that mean that authenticating a password or with a certificate, right? In terms of the ILO example that was shown, that does authenticate via certificate, right? So KMIP authentication is done via certificate. There was, shown a user created on system, but what wasn't really shown as part of the configuration process and what happens when a client registers with the system for that key exchange is that there is a certificate authority that runs locally on CipherTrust Manager, which will issue a certificate for that client with the username as the common name of that certificate, which is then used to authenticate that connection between the client and the CipherTrust Manager. For other use cases, it might be just a username and password, or you might be utilizing some other external authentication like SAML or LDAP or OIDC.
Okay, I think we went through all of the questions today. All right.
Yes, thank you very much, Jeff, Chris, and Jerome. I think you did a great job answering all these questions. And I really thank you for delivering that session. We will have another meetup next month. Thank you, everyone, for staying up with us. I will leave the poll 1 more minute so you get a chance to answer the questions. And I will say thanks and goodbye, everyone.
Thank you.
Thank you.
Thank you.